Welcome all. Thanks for coming to our event. And I want to give just a short preface. So thanks to Sriram for giving an insight on what he thinks of AGI, what's the role of community, and everyone contributing towards AI, and especially the ethos of crypto, which is permissionless innovation. And he ended up with this keyword loyal and loyalty, a very non-technical and a very emotional human word, but very close to AI. So when I talk of AI, if I want to look at who's consuming AI, the whole world is consuming it. Nearly every consumer, man, woman, child, all businesses, huge impact. That goes without saying. Somewhat, less obvious, but it's also clear for everyone in AI, is that it's a very accessible technology. I've been around for a few decades doing technology since I'm an old-timer, since Web 1. And it's a very accessible technology compared to, let's say, some other things we've done before. Shake and bake, I call it. And very large developer base. And if you include energetic, excited, starting with high school students, you have tens, if not hundreds of 100 million potential developers. A very large number of applications to do. If I look at such a large landscape, everyone in humanity using it and businesses, and so accessible developer base, surprisingly, in terms of delivery and building, it's very restricted in what you can do. Either you do the closed world, which is the big corporations, the trillion-dollar market cap corporations, Open AI, aka closed AI, or you go the open route, you work on some open source models released around, and you freely given away. You upload your innovations on Hugging Face, and it's a permissionless innovation. The huge advantage is that, of course, you can innovate, accessible, but there is no flexibility or any programmability around how to monetize, how to build, and moreover, how to control it. And this kind of a dichotomy forces innovation on the left to reach customers through a very narrow pipe. So if you're I'm a professor at Princeton University. I've been a professor for some time, and the students who work through it basically have to prove themselves through their innovation, not by actually developing anything, but submitting themselves to this treadmill test, which is to go through, put their repos on, let's say, GitHub or Kaggle or Hugging Face, depending on what you're specifically trying to do, and hope for downloads, pull requests, stars, basically some kind of brownie points that you did well. And if you're an academic and like somewhat researcher, then you go submit to some academic conferences and hope for citations. It's kind of a rough game. Why? So that you can put one line on your CV, go all along this narrow pipe, and apply for a job at the big corporations. Kind of a sad situation in terms of how much available to the tech is to developers, how badly they are needed, but you go through this narrow pipe. Kind of a societal problem, really. And the goal that I've been largely thinking about is to even this access, which being able to take your innovation and go directly to applications. Most of all, be able to make a living out of it. So the first word about making a living is monetization. And I should be able to share the model openly. One way to monetize, of course, this is a standard business. You build it, you keep it to yourself. Perhaps an old school way is to trademark it or patent it. Hard to do both in AI. So usually what people do is to just keep it closed and build a vertical business model, which is the traditional closed model. The trouble with this, of course, is that it's a very, very heavy lift. And that's why very few companies can succeed. The other aspect, less known, is that you have to do everything yourself. It's not permissionless innovation. Other people can't build easily on you. And in a way, but I would like to be open. So that way it has the ethos of crypto, allows permissionless innovation to build on top, yet have ownership. Ownership means I should be able to track usage and associated economic value. Kind of like think of it as property rights, the bedrock of our civilization, but for AI. It went through, software engineering went through this way back when Microsoft was giving away Microsoft Word. They came up with this idea of .exe formats, executable, so you can't reverse engineer the source. They put they hid some ways in which licenses can be checked, and that's how they worked around. And I'm asking here, what's the .exe equivalent of a neural network or a model? That's on the monetization side, and that is tracking usage. The bigger thing is to track appropriate usage, which is I should like it to be used in a way that is appropriate to the ethos and what you may call my own wish on how it should be used. In AI, this is known as safety or alignment, and largely both AI development and alignment get mixed up, making it a significantly complicated thing to do both. And thinking of it this way, releasing openly yet controlling it, kind of decouples these two problems. The question is, how do you do this? You want to release it away, give it away to people, yet control it. It kind of seems like an impossible question, except cryptography does magic, which is that it tries to do things that are, seem impossible. And cryptography addresses this problem too. It's called I/O. And one of the grandest challenges in cryptography, solving this is so-called crypto complete. Essentially, every open problem in crypto gets resolved. The thing with I/O will resolve OML, open but monetizable and loyal. But the thing is, even theoretical understandings are hardly there, not to mention very, very far away from practicality. So crypto is not getting there. But I would like to work on this. This is at the heart. Building an OML, it's a library. Think of it as a cryptographic primitive, hash function or a signature, yet it's an ML library. So .oml is a neural network file format. You replace .onnx, .tf, .safetf with .oml. And it's like an ML library and a crypto library built together. But cryptography is nowhere ready. So how do we do this, and what do we do is the core heart of what I've been working at, and the Sentient sort of main focus from a scientific perspective and an engineering perspective. And the way we do it is not by trying to solve the oldest problem in cryptography, but taking a new look at the kind of applications that we have here. In cryptography, the bar is high. You want security in a worst case way for every input and exactly right and for decades long. In AI, first of all, the data is not discrete, it's continuous. So you can already think of some kind of squishing. If you're approximately somewhere there, I'm okay. Second, I don't have to be worst case. If once in a while some prompt squeeze through my model, it's okay, big deal. As long as the majority are used correctly, I'm good with it. And finally, models get obsolete in 6 to 9 months anyway. So I don't need like 2-decade or 3-decade security. I want a 9-month security. And last thing is that security is not black or white. In AI, if you pay me and be controlled by me, your model works as prescribed, like GPT-4 or O1. If you don't, it becomes 3.5. That's okay. So there's a sliding scale to security. And we use these kind of basic primitives to use AI itself to build OML libraries. And there's a precedent in which I myself worked on. And my background is information theory and codes theory and coding theory. And in the history of communications, like wireless, there have been just a few codes that went over the wires and over the air. And we've been building, using AI itself to invent new families of codes that are new state of the art. Think about, if you're curious about this, you can look up KO codes, knockout codes from our research. So there is some precedent of doing mathematical objects with AI itself. And this is a similar spirit, a call for bringing AI itself to build new crypto libraries, especially the kind that we want here for AI, because we use AI itself to build OML. We talked about it at length at a symposium, very similar to this, except more academic and somewhat focused at Columbia a few months ago. We released sort of a scientific paper associated with what OML is, defining it mathematically, and showcasing the first set of solutions. And that was also a couple of months ago. And today is a day where we are happy to sort of talk about it from a very engineering and usability and product viewpoint. For that, you'll have to wait out just a bit longer, a few more hours, and my colleague will be talking about it. Thank you. If we have a few minutes, it's a great time. Welcome all, and we can take questions.
Hello, Professor. Thank you for the sharing. I'm asking about how to balance the efficiency and try to protect also the privacy of the data part. Thank you.
This is a model, and privacy is somewhat kind of an orthogonal aspect, which is what data went into the model, and it's kind of separate. This is about ownership rights. And how you want privacy is something kind of separate. And what is privacy, what do you want to protect is kind of orthogonal to this.
For example, like say privacy, AI inference or something?
You know, one thing good question actually, which something I did not allude to at all when in all my slides. When people think of crypto and AI, this is a good time to actually bring it up. What we think of crypto AI is not, I told what it is, I think, but what it's not is that one may have thought of decentralized inference or decentralized training. I mean, it's hard enough to do them centralized, and trying to do them decentralized is kind of a Herculean thing. It's not something we focus on. And there are multiple sort of simpler ways to go around that. And I would like to allude to a sort of a series of white papers we wrote on this, of talking about which part should be decentralized, which is the way to think about it as a stack, and the core heart of it comes down to ownership.
That makes sense. Thank you, Professor.